Hey viewers, welcome to my channel Tech. This is the 11th video in the series of Python programming, and in this video we're going to discuss about different classes of Python operators. So these are the topics we'll be going through. So these are the classes of operators: arithmetic, assignment, comparison, logical, identity, membership, and bitwise. Let us see them one by one. So the first one is arithmetic. So you're pretty much aware of these operations. So addition, it's given by plus, it performs numeric addition, and subtraction is given by the symbol minus, that performs numerical subtraction. Likewise, multiplication is done by star, division by backward slash, and there's something called as floor division where you use double slash, right? So when you perform normal division, you get the floating point number, you get the actual division value, right? It can support floating point output. When I perform floor division, it is like an integer division. The output will only support integer. So rather than 2.5, you will get only 2, the integer value. And modulo division, modulus, this is pretty much the same symbol that is used across multiple programming languages. So 5 mod 2, that gives you the remainder. So 5 divided by 2, that goes for 2 times, and remainder is 1. So you get the remainder here. And there is something called exponentiation, which is nothing but what we call as power, right? So normally we use the cap symbol in many programming languages, 3 power 2, the 3 cap 2, right? So instead of cap here, in the cap is used for some other purpose, which we'll see shortly, right? So instead of that, in Python we are using double star. So instead of the cap symbol, we are using double star, which means power. 3 power 2 is 9, 3 square. It's basically 3 square, right? So these are the arithmetic operations. And when you deal with arithmetic operations in programming languages, so you need to understand the priorities of the operations, right? So the priorities you can remember by this simple code word PEMDAS, right? Here the P stands for parenthesis. So the parenthesis is the normal brackets that you use pretty often, right? So this set of brackets, right? So this has the highest priority. Whatever expression is inside the bracket, right, that expression will be solved first. So parenthesis gets the highest priority, followed by exponentiation. So this one gets the next priority, highest priority, and multiplication gets the third, division gets the fourth, and addition gets fifth, and subtraction is the last one. Say for instance, I have something like this: 3 minus 2 star 4, right? So normally subtraction gets the least priority, right? So let me add something else here. Okay, let me make it more interesting. Sorry, so that you can understand this priority better. Plus 5 star 2, right? So when you look at this, when you think of subtraction, it has the least priority, so you might jump to the conclusion that we should perform this last. But this subtraction is written inside a parenthesis. Okay, so first you need the expression, execute the expression within the parenthesis. So 3 minus 2, you will get 1. So the expression is reduced to 1 plus 5 exponentiation of 2. Now there is an addition and there is an exponentiation. So which gets the highest priority? Exponentiation gets the highest priority. So you have to perform this 5 double star 2. So 5 square, it is 25. So then you get 1 plus 25. So the answer is 26. So this is how the priorities work. So the parenthesis gets the highest priority, followed by the exponentiation. After that you perform the addition, right? So this simple code word PEMDAS, you can remember it so that you can understand the priorities of the arithmetic operations. So the next one is assignment operators. So these are the assignment operators. So this is pretty much similar to your C code, C programming. Okay, so first one is a normal equal to operator. So a equal to 5. What it does, it assigns the value of 5 to the variable a. That is why we call this as assignment operators. So the expression on the right side is executed, and the answer is assigned to the variable on the left side. So we are assigning, that's why it is called as an assignment operator. So you see here, initially we have assigned the variable 5, the number 5 to the variable a. So let us use this a variable to execute the rest of the expression, right? So a plus equal to, the next operator is plus equal to, so a plus equal to 3, that is equivalent to a equal to a plus 3. You might have seen this on C program if you are aware of C program, if you learned C program, you might have seen these expressions, right? So a plus is equal to 3 is equivalent to a equal to a plus 3. So we have 5 here, so the answer will be 5 plus 3 equal to 8. Then we have minus equal to, which is same as a equal to a minus 3. So 5 minus 3 is 2, so the answer is 2. Then we have a star equal to, which means a equal to a star 3. Okay, so a is 5, 5 into 3, 15. The answer will be 15. Then we have a slash equal to 3, which is equivalent to a equal to a slash 3. So 5 divided by 3, so you will get 1.67. Then a mod equal to 3, so this is equivalent to a equal to a mod 3. So 5 mod 3, the remainder will be 2, so a equal to 2. Similarly for the integer division, so a equal to a double slash 3. So 5 double slash 3 means, so it will go 1 time, so the answer will be 1. Then exponent, a equal to a star star 3. So 5 star star 3, so 5 cube. 5 square is 25, then 25 into 5, it is 125. The answer will be 125. Okay, so this is nothing but a cube is nothing. This is a power star star 3 is nothing but a cube. If I have a star star 4, I'm sorry, then it is equivalent to a power 4. So this is like a power operation. So these are the assignment operators. So why we are calling them an assignment operators? I'm repeating again. The expression on the right side is calculated, and the value obtained is assigned to the variables on the left side. That is why they are called as assignment operators. And the next one, we have comparison operators. So these operators are mostly used in conditional statements. For instance, like your if loop, while loop. So we use these operators there. So these are the different operators. So we have double equal to. So please remember, in the previous slide we have that equal to is an assignment operator. So what it does is assigns the variable on the right side. It assigns the value on the right side to the variable on the left side. But here equal to, double equal to, what it does is it compares the variable on the right side to the variable on the left side. If both are equal, it gives you true. Okay, it is not assignment, it is comparison. So 5 equal to 4, it's not equal, so the answer will be false. You can try executing this in your idle. Okay, so since these are simple concepts, I am not executing in idle. You can try this on your own. So 5 equal to 5, they are both equal, hence it gets true, right? Then not equal, so you get an exclamation symbol followed by equal to. So 5 not equal to 3, this is true, it's not equal to, right? Sometimes you may get a loop statement, you may write a loop statement, if, right? You have two variables a and b. If a not equal to b, so only if this condition is satisfied, then you will write the set of codes for this. So that is why these comparison operators are mostly used in conditional statements. Then we have greater than, you are aware of that. 3 greater than 5, it is not greater, so the answer will result in false. So you will get a logical answer, either true or false. Then you have less than symbol, 3 less than 5, that is true, so you get true. Greater than or equal to, yes, it is true, since both the terms are equal, you will get true. Less than or equal to, again, since both the terms are equal, you will get true. So these are some of the comparison operators. And the next one, logical operators, right? So we have 3 types of logical operators. So basically, logical operators are used to combine conditional statements. So previous case, I have given an expression, right? If a not equal to b, okay? So what if I have another condition? So I have to check a is not equal to b and a is equal to c. Only if both the conditions are satisfied, I need to do something. Okay, that is, the loop statements have to be executed. So this is where logical operators come into play. They can combine multiple condition statements. Okay, so let us check here. So the first one is AND. AND means both the conditions have to be satisfied. See here, I am giving x greater than 5 and x greater than 10. Let us assume that the value of x is equal to 8. So here x is greater than 5, yes, definitely 8 is greater than 5, and x is less than 10, yes, it is less than 10. Both the conditions are satisfied, then it will return true. Okay, so when I say if a not equal to b, or if and I'm very sorry, and if if A not equal to B and A equal to C, both the conditions have to be satisfied. That's the case here. If x greater than 5 and x less than 10, both the conditions have to be satisfied. If I use OR, it is enough if it satisfies any one condition. So x greater than 5 I am checking, it will satisfy the condition. So there is no need to check the second condition itself. So when the first condition is itself satisfied, then the value will be returned true. Okay. Suppose if the first condition fails, it will check the second condition. Then if it gets true in the second condition, then it will return true. Only if both the conditions are failing, we will get fail. And third case is not. It provides a result of the, opposite of the result. So not of x less than 5. 8 less than 5. This is false actually. 8 is not less than 5. So the answer is false. Not, what it does is, it reverses the condition. So what you will get here, you will get true. So the expression inside the brackets result in false, not will reverse the answer, so you will get true. This is the logical operators. Then we have an interesting set of operators called identity operators. So identity operators are used to check if two objects are the same with the same memory location. So let us see here. There are two operators, is and is not. X is y returns true value if both are the same object. See, what is the difference here? So we have already seen x equal to y. Now this is x is y. So what is the difference here? Let us say I have given the value x equal to 2 and y is also 2. So in this case, what happens is, x is given taken a particular memory location and the value is given as 2, and y has a different memory location, right, and it has a value 2. But in the same thing, when I check for x is y, this will give me true only if both the variables are assigned to a same memory location with the same value. So here the comparison is done with respect to memory location, whether both the objects are sharing the same location, then it will return true. I hope you understand the primary difference between equal to and is not. That's opposite of is, right? So if they are not the same object, if they are not sharing the same location, then the condition will be true. Okay. And the last set, before that we have some membership operators. Membership operators are used to check if a value or sequence is present in an object. So this will be clear when you see an example. So first operator is in, second operator not in. 4 in 1 4 minus 3 7. So whether this 4 is present in this sequence. So it is there. So you will get true. So you can check a value or a sequence. Suppose I am giving here, instead of 4, I am giving 1 comma 4. This will again return true because 1 comma 4 is present in there. Okay. Not in. So if it is not present, it will return true. So I have given 2 here. 2 is not present, it will return true. Suppose instead of 2, if I give 4 here, then it will return false because 4 is present there. Okay. So these membership operators, they are mostly used in conditional statements or for loops. When you are writing for loops, which you will see in the future videos. So for I in A. So I is the loop variable, A is a variable containing a sequence like this, right? Likewise, we will give a statement. So the in statement will be primarily used in for loops. Then at last we have the logical statements or the bitwise operators, which performs binary operations on the given numbers. So here I have given some illustration. First one is the AND operation. So 3 and 2. So the binary for 3 is 1 1 and the binary for 2 is 1 0. Okay. So it will perform bitwise AND operation. So here the LSB and LSB 1 into 0, 1 and 0, which is 0. AND operation gives 1 only when both the inputs are 1, right? So here one input is 1, another one is 0, so the answer will be 0. And again it goes for the second one, 1 and 1. So 1 and 1, the answer is 1. So what I am getting result 1 0, the corresponding decimal is 2. Now let us go for OR statement. Same numbers we are repeating. We are going for OR statement. So 1 1 1 0. What happens when OR statement? Only when both the inputs are 0, the answer will be 0. Otherwise the answer will be 1. So again if I take LSB, 1 and 0. So we are getting one input as 1. So the output will be 1. Then we are going for the next bit 1 and 1. Both inputs are 1, output will be 1. So I am getting the answer as 1 1. So the result will be 3. Then I have the cap symbol. Now you understand why we are not using cap for power. In Python we used a double star for power operation, but in other programming languages normally the cap symbol will be used. So here the cap is used for a bitwise XOR operation. Again, let us take the same example. You know XOR operation, it gives a high output only when one of the input is high. So one has to be high, other has to be low. Only in that case the output will be high. So if you check here, here it is 1. If I check LSB, here it is 0. So 1 0, 1 is high, 1 is low, so the output will be 1. If I go for the next bit, here 1, here 1, both are 1. So both are 1 means output will be 0. So the answer is 0 1, corresponding decimal is 1. Now left shift, 3 left shift 1. So this is left shift, right? I am having, this is 3. I need to shift this left. So this 1 will be shifted here. This 1 will be shifted here. Now this place will be empty. The empty spot will be replaced by a 0. Okay, so what I am getting? 110. The 110 for corresponding decimal is 6. Okay, I hope you understand. So if we assume like this, initially I had 1 1, right? This is given. Now what happens? This one will be shifted here, so it will come here. This one will be shifted here, it will come here. Now the LSB spot is empty. So here it will be replaced by a 0. So the answer is 110, corresponding decimal value is 6. Next, right shift. So again I am having 1 1. Okay, now I am taking the right shift. So when I perform right shift, this is the LSB. There is no place beyond this. So when I am shifting this outside, so this one will disappear. It will go off. And this one will come here, and this place will be empty. Okay, so that empty space is replaced with the 0. So I will get the 0 1. This one will be pushed out of the sequence. It cannot go beyond LSB. Okay, so 0 1. The corresponding decimal value will be 1. So these are the bitwise operators. So these are the different classes of operators in Python. So thank you for listening patiently. If you like the video, hit the like button. Do give your valuable suggestions in the comment section. And if you want more videos like this, subscribe to my channel. Thank you, viewers.